We are going to start now the chapter 7 of class 9th mathematics, triangles. So we have divided this chapter in 4 lectures. In the first lecture we will talk about some basic definitions related to triangles. Now the first definition we have, it is triangle. So it is a plane figure bounded by 3 line segments. So bounded by over here means that it is a closed figure. 3 line segments may be like this also, but they are not bounding anything. Bounding means that it should be a closed figure. So we are saying the 3 line segments, this AB, then AC, and then BC are there, which are intersecting at these 3 points. So they are bounding a region. So that is called a triangle. And this A, B, and C, this A point, B point, and this C point, these 3 points are called the vertices. A, B, B, C, and C, these are called the sides, and these angles B, A, C, then A, C, B, and C, B, A, these are the angles over here. Now next we have are the types of triangle on the basis of the length of their sides. The first definition we have over here, it is equilateral triangle. So equilateral triangle are those in which all the sides they are equal. So we have drawn a triangle over here, A, B, C. This is the triangle. And how we are representing the sides are equal? We mark this like this. That we are marking a line over here. What this thing means that AB is equal to AC, and we are drawing the third line over here. So what these 3 lines are representing, that AB is equal to BC is equal to CA, that is all 3 sides these are equal. In the triangle in which all 3 sides are equal is called an equilateral triangle. Next is the isosceles triangle. Isosceles triangle is in which 2 sides are equal. A triangle in which 2 sides are equal. So over here we have marked, we are saying AC and AB, they are equal. So it may be triangle like this, that these 2 sides are equal. We are saying A, B, C, and this side is not equal to these 2 over here. So 2 sides in which a triangle in which 2 sides are equal is an isosceles triangle. Now one important thing to note over here is, if suppose I am talking about that if a triangle is there whose all the 3 sides are equal, so it is equilateral triangle, all 3 sides are equal. Now this triangle also has 2 sides equal, so it is also an isosceles triangle. So we are saying all equilateral triangles are isosceles triangles. Next is the scalene triangle. So scalene is in which no sides are equal. That is, we are talking about this triangle PQR, we are saying. So it is scalene means that PQ is not equal to QR is not equal to PR. Next definition we have is the perimeter of a triangle. So the sum of the lengths of 3 sides of a triangle is called its perimeter. So we are saying if a triangle ABC is given, ABC, so perimeter of the triangle means the length of side AB plus length of side BC plus length of side CA. That is the perimeter. So we do not write length every time. We just write it like AB plus BC plus CA. So that is the perimeter of the triangle, that is length of the sides. So perimeter basically means if we start moving from the point A, and we reach on this triangle, we reach point C, then we move from C to B, then we move from B to A. What is the total distance that we have triangle? That is, what is the total length of this edges of this triangle, that is the perimeter of the triangle. Next is the last definitions we have done. It is the types of triangle based upon the sides. And now we have the types of triangle on the basis of the angles. So first definition we have over here, it is right angled triangle. So right angled triangle is a triangle which is having one angle as right angle. We will see further that a triangle cannot have more than one angle as right angle. So that is the next part of our next slides. So the definition we have over here, a right angle triangle means a triangle in which one of the angle measure is 90 degree. Then it is called the right angled triangle. Now there are some terms over here. We are saying, suppose this is the triangle we are talking about, and this is a triangle ABC, and it is right angled at B. Then this BC, this is called the base, this AB is called the perpendicular, and this AC is called the hypotenuse. BC is called the base. These terms you have to keep in mind. AB is the perpendicular, and this side which is opposite to this angle, this 90 degree angle is over here between AB and BC, this side opposite to this angle, that is called the hypotenuse. Next is the acute angled triangle. So a triangle in which every angle measures more than 0 degree but less than 90 degree. You know what acute angle is? The angle which lies between 0 degree and 90 degree, they are acute angle. So we are saying every angle measures 0 is between 0 and 90. It means every angle is an acute angle. Then the triangle is called an acute angle triangle. Next is the obtuse angle triangle. So a triangle in which one of the angles, so a triangle in which one of the angle measures more than 90 degree, then that triangle, and less than 180 degree, then that triangle is called an obtuse angled triangle. So this is also shown over here that one of the angles over here, this angle we are talking about, this is an obtuse angle. So any angle can be there. It is not necessary that this angle, it may be P, Q, in any one of the three angles that can be obtuse. So if one of the angles is obtuse, then it is called an obtuse angled triangle. Next are some other terms related to the triangles. So first term is the median. So if a triangle is given to us, then the median of a triangle corresponding to any side is the line segment which joins the midpoint of the side with the opposite vertex. So we are saying, suppose we are given any triangle over here. Suppose this is the triangle given to us, and this is A, B, C. We are supposed talking about the median of the side BC. Median of the side BC, this is our side BC. We are talking about is median corresponding to side BC. It means we are talking about, we will find the midpoint of BC. This is midpoint of BC, and we join the point, this midpoint, to the point A, the vertex of the, this is vertex opposite to BC. So this line is called the median corresponding to the side BC. If this point is G, then we say the median corresponding to side BC is AD. So median is basically a line. So what we have to do to find the median? Suppose I have to find the median corresponding to AB. So we are saying we will find the midpoint of AB. Suppose that point is F, and we will join F with the opposite vertex. Then this line is the median corresponding to AB, and similarly we can find the median corresponding to the line AC. Now it is a property of the triangle that the medians are concurrent. Concurrent, we know, one definition we have done, it was intersecting lines. So intersecting line was when two lines are there and they meet at a point, then they are called intersecting. Concurrent means that three lines are there and they are meeting at one point, then this, it means they are concurrent. So medians are concurrent means that all these three medians, they meet at the point G. We are calling this point as G, and the point where these three medians they meet, that is the called the centroid. So centroid is the point where all the three medians they meet. The next definition we have, it is the altitude. So altitude, basically the another definition you can say, or from what you can get the idea is, altitude is basically is the perpendiculars we are talking about. So we are again considering a triangle. So this is the triangle we are considering. This is A, B and C. When we are talking about the median, we are saying suppose median corresponding to BC, we find the midpoint of this BC and we join this point with A, then we are saying it is the median. Now what we are going to do is, we are saying the altitude of a triangle corresponding to any side is the length of perpendicular drawn from the opposite vertex. Now we are not finding the midpoint over here. Now we are saying from this point A, we have to draw a perpendicular on BC. We are drawing a perpendicular on this BC. Suppose it is at this point L. The midpoint over here, it was D or somewhere over here, maybe D over here. We are saying this is the point L. So this is the altitude. So length of this AD, we are saying the length of this perpendicular, this AL is the perpendicular, and the length of this perpendicular, length of perpendicular AL is called altitude. Altitude is basically we are talking about is height. So we are not using the word height over here. We are not using the word height over here. In place of height, we are using the word, it is altitude. This is a standard word. So we are saying AL is the altitude corresponding to the side BC. Similarly, we are saying BM is the altitude corresponding to the side. Over here we are drawing the perpendicular over here. This is the perpendicular over here. So BM is the altitude corresponding to the side AC, and CN. You are drawing like this, that CN is the altitude corresponding to the side AB. So altitude is the length of the perpendicular on the opposite side from the vertex. Now the altitudes of a triangle, they are also concurrent. They will meet at a point. The altitude of a triangle, they are also concurrent. They will also meet at a point, and this point where they will meet, it is called the orthocenter. These terms you have to remember. That last we have done, it was medians. Median was we are taking one side, we are finding the midpoint of that side, and we are joining that point to the point opposite vertex. The medians are concurrent, and the points where they meet, it is the centroid. Similarly, when we are talking about the altitude, altitude is the length of the perpendicular drawn from the vertex to that opposite vertex to that line of side of the triangle, that is called the altitude. The altitudes are also concurrent, and the points where the altitude meet, that is called the orthocenter. Next is the definition of incenter of a triangle. So the point of intersection of internal bisectors of the angle, that is called the incenter. So we are saying suppose a triangle is given to us. In the first case, we were talking about the median. So median was, we have, suppose I am talking about, this is the triangle ABC. I am talking about the median of BC means I will find the midpoint of B and C, and I will join this midpoint with the point A. Then that is the median. Second we are talking about is the altitudes. Altitude means from A we are drawing a perpendicular. This is, we are saying we have drawn a perpendicular on BC. Then this is the median. Median means the length of this side and this side, they are equal. Altitude means we are talking about that we have drawn the perpendicular from the vertex. This is the point D over here. Now the next we have it is in center. In center we are saying corresponding to A, we are going to draw is the angle bisector. Suppose the angle, this angle A, we will draw the bisector of this angle over here. Then this line, this is called the angle bisector of A. Similarly, we will draw the angle bisector of B, and we will draw the angle bisectors of C. Angle bisector of B means this is the whole angle. These two angles, they are equal. Angle bisector of C means this is the whole angle. Then this part and this part. This is the angle bisector. The point where these angle bisector meet, that is called the in center. So that is shown in the figure, that the triangle is given A, B, C. That is the triangle. We have drawn the angle bisectors over here. These are the angle bisectors. The point where they meet, that is called the in center. So if we draw a circle with center I and radius ID, this is our length ID. If we draw a circle with radius I and ID, that will be a circle inside this triangle, and that will touch the sides of the triangle, and this circle is called the in circle. This point I, that is why it is called the in center, because it is center of in circle. In circle, basically the definition of in circle is we have to find a triangle is given to us. We want to draw a circle which touches all its sides. Touches all these sides means it is touching this point. It is not, one is that is, suppose I draw the circle like this, it is intersecting at 2 points over here. It is intersecting at different points. It is not intersecting, it is just touching these points. Then this circle, this circle is called the in circle of the triangle. The center of this circle is basically the in center, and what we have is that in center is the point where the angle bisectors meet. Now the next definition we have, it is circumcenter. I am again repeating what we have done. A triangle is given to us. We are saying, suppose we are considering this side over here. We find the midpoint of this side. We join this midpoint to this point. Then we are saying this line, this is the median. This is just bisecting the opposite side. Next thing we have done, a triangle is given to us. Then from this vertex we have drawn a perpendicular over here. It may bisect, it may not bisect, we are not interested in that. The length of that perpendicular is called the altitude. Next thing we have done is, again a triangle is given to us. We are saying we are drawing the angle bisectors over here. This is the angle bisector, this is the angle bisector, and this is the angle bisector. Angle bisector, we are saying it is dividing in these angles in two parts. Then this point, this is called the in center. Next definition we have done, a triangle is given to us. We are drawing a circle over here which touches this triangle at these three sides. This is inside the triangle, first thing. Number two, it touches all three sides. This what touches is there, it is not intersecting. There is difference between these two things that you will learn in your next chapters. So we are saying this circle is called the inner circle, and basically the center of this circle is the in center that we have obtained from the angle bisectors. Now next definition we have, it is the circumcenter and circumcircle. So circumcircle is basically, we are saying a triangle is given to us and we have to draw a circle passing through these three vertices. These are the three vertices of the triangle. We want to draw a circle which passes through three vertices of triangle ABC. Then that circle is called the circumcircle. And the center of this circle is called the circumcenter. Now what is the procedure to find this is, when we are finding the inner circle, we have drawn the angle bisectors. When we have to find the circumcenter, we are going to draw is the perpendicular bisectors of the side. Perpendicular bisector of the side means if this is A, B, C, I am drawing perpendicular bisector of AB. So what I have to do, I will keep the compass at A. I will mark two arcs over here. I will keep the compass at A. I will mark two arcs over here. Arc over here. Similarly from B, I will mark the arc and I will join these two and I will get the, this is the perpendicular bisector. Perpendicular bisector means that it is dividing this AB in two parts, equal parts, and this angle is 90 degree. When we are talking about the altitude, there are two different things we are saying. We suppose this is the triangle. This is A, B and C. When I am saying the altitude I am saying from the point A, I will draw the perpendicular on BC. That is the altitude. The length of that perpendicular is the altitude. When I am talking about the perpendicular bisector of side BC, it means I am saying this BC is there. This is the midpoint of BC. This point over here marked with green, it is the midpoint of BC. If I will draw a perpendicular at this, that is the length of this is the altitude, and this line is representing the perpendicular bisector of BC. Similarly, we will draw the perpendicular bisector of AC, and similarly we will draw the perpendicular bisector AC and AB. The point where these three perpendicular bisectors meet, that is called the circumcenter. So the point of intersection of the perpendicular bisectors of the sides of a triangle is called the circumcenter. Now if with this as the center and this point circumcenter as the center and the radius, say we are saying this O we are saying, and the radius OA we are considering, if we will draw a circle, we will get the circle which passes through the three vertices of this triangle, and that circle is called the circumcircle. The next definition we have, it is exterior and interior opposite angle of a triangle. So suppose a triangle is given to us. We are talking about this triangle ABC. This is the triangle given to us, and we have produced the side BC to the point D. This is our side BC which we have produced to D. Then angle ACD is called the exterior angle. This angle we are talking over here, this is called the exterior angle, or it is called the remote angle. And corresponding to this angle, the angle ABC and the angle BAC, corresponding to this angle, these two angles, these are called the interior opposite angles. Corresponding to the angle ACD, exterior angle, this angle A and angle B, these are called the interior opposite angles. Now the next theorem we have is that the sum of angles of a triangle is 180 degree. So to prove this thing, we are considering a triangle A, B and C, and we have made a construction that through A draw a line DAE parallel to this line DAE we are drawing, it is parallel to BC. We are saying this GAE line, this is parallel to BC. Now what we get is, we have marked these angles over here. This is angle saying 1, 2, 3, 4 and 5. Now what we have is, angle 3 is equal to angle 4 and angle 2 is equal to angle 5. Why? Because these are alternate interior angles. Now look at this point A over here. At this point A we are having 3 angles and they are lying on a line. All these 3 angles, they lie on a line. It means the sum of these 3 angles is 180 degree, that is angle 4 plus angle 1 plus angle 5 is equal to 180 degree. Why? Because BA is a straight line and all these angles, they lie on the same side of DAE. So now if we use this condition over here, in place of 1 we can write it as angle 3 plus angle 1 plus, in place of 5 we can write angle 2. We are saying in place of 5 we are writing it is angle 2. In place of 4 we are writing it is angle 3. So what we get is, the total value over here, it is equal to 180 degree, and this is what we have to prove, that the 3 angles of a triangle, the sum of 3 angles of a triangle is 180 degree. Now the first thing we have to note from this is that suppose one angle, more than one angle of this triangle is 90 degree, then what will happen? Suppose I am saying this angle is 90 degree, this angle is 90 degree, we are left with angle 2, so we are having 180 degree, so angle 2 is equal to 0 degree. So it will not form a triangle. So first thing we are talking about is that a triangle cannot have more than one right angle. Next, if one of the angles is obtuse angle, then suppose we are saying the one angle is say 90, or we are saying it is 100 degrees. Next angle we are saying say it is 95 degrees. Then what is the angle 2? It will, this value will become negative. So both these cases, these are not possible. So we are saying a triangle cannot have more than one obtuse angle, and in a right triangle the sum of two acute angle is 90 degree. So this is, these 3 things, these are clear from this theorem, that the sum of the 3 angles of a triangle is 180 degrees. Next is, if a side of a triangle is produced, then the theorem says that the exterior opposite angle, the measure of exterior opposite angle, that will be equal to the sum of the the exterior angle, that will be equal to the sum of the interior opposite angles. So the figure is drawn over here. This is the A, B, C is there. Then we are saying this angle 4, this is the exterior angle. Angle 1 and angle 2, these are the interior opposite angles. So we have to prove is that angle 4 is equal to angle 1 plus angle 2. So what we are going to use is, we are saying the sum of the angles of the triangle, that is equal to 180 degree. This is from our previous theorem. Second thing, these two angles, angle 3 and angle 4, these lie on a straight line, on the same side of a straight line. So their sum is also 180 degree. So if we subtract these two equations, we will get it as angle 1 plus angle 2 minus angle 4, that is equal to 0 degree. So angle 1 plus angle 2 is equal to angle 4, and this is what we have to, that the exterior angle, that is angle 4, we are saying that is equal to the sum of the interior opposite angle, angle 1, and the sum of angle 1 and angle 2. Next is, an exterior angle of a triangle is greater than either of the interior opposite angle. So we have to prove that this angle 4, this is always greater than the angle 1 or angle 2. So what we are saying from this last result, we have angle 1 plus angle 2 is equal to angle 4. So the angles, the value of these angles, these are positive. So it is clear that angle 4 is greater than angle 1 and angle 4 is greater than angle 2, because we are adding, if we are talking about the angle 1, we are adding some positive number to it, and the answer we are getting, it is equal to angle 4. So it means that angle 1 is less than angle 4, and for the similar reason angle 2 is less than angle 4. Now in the next question, it is given that the angles of a triangle are in the ratio 4:5:6 and we have to find the angles. So suppose we are saying for some constant x, this is any triangle given to us, and the angles will be 4x, 5x and 6x. You know that the sum of the angles of a triangle is 180 degree. So the final answer we will get, it is 15x is equal to 180 degree, x is equal to 12. So you will find that the value of the three angles, it is 4x, 5x, 6x. So the answer is 48, 60 and 72 degrees. Now the next is, in a triangle, 2 times angle A is equal to 3 times angle B is equal to 6 times angle C, and we have to find the angles. So suppose we are saying that 2 times angle A, 3 times angle B is 6 times angle C, and let they all be equal to some constant K. Then you will get value of angle A is K by 2 when we are equating these two terms. Next we are equating these two terms, you will get 3 times angle B is equal to K, means angle B is equal to K by 3. Next we are equating these two terms, so we will get 6 times angle C is equal to K, so angle C is equal to K by 6. So from the property of the triangle, we have the sum of these three angles, it is 180 degree. So we will get K by 2, that is angle A, plus angle B plus angle C. The sum of the three angles, it is K by 2, K by 3 and K by 6. The sum of these three angles is equal to 180 degree. So you will take 6 as the LCM over here. When you will take 6 as LCM, you will get the answer as, it is 3K plus 2K plus K over 6 is equal to 180 degree. So the value of K you will get, it is equal to 180 degrees, and we have to find the angle. So A is K by 2, so K by 2 means the value of A is 90 degree, value of B is 60 degree and value of C is 30 degree. Now in this next question, it is given that in a triangle ABC, angle A plus angle B is 65 degree and angle B plus angle C is 140 degree, and we have to find the value of the angles. So we are saying, so this is angle A, this is B, this is C. Now the sum of the angles of the triangle, angle A plus angle B plus angle C, that is equal to 180 degree. What is given to us is that angle A plus angle B is equal to 65 degree, and second is angle B plus angle C is equal to 140 degree. So what we do is, we find the value of angle B from this, or find the value of angle A from this. So angle A is equal to 65 degree minus angle B. You try to find the value of angle C from this, it is 140 degree minus angle B, and we substitute the value of angle A and angle C in this equation. So we will get, it is 65 minus angle B plus angle B plus 140 minus angle B. What we have done, we have substituted, this is the value of A, and this is the value of B, and the final answer we know it is equal to 180 degree. So on solving these equations, you will get the value of angle B is equal to 25 degrees. Now angle A we know it is 65 minus angle B, and angle C is 140 minus angle B. So when you will substitute these values, you will get angle A is equal to 40 degree, angle B is 25 degree, and angle C is 115 degrees. So what we have done in this case, we have seen that the value over here we are talking about in both these equations, these two equations I am talking about, we are saying from this equation we have written the value in terms of angle B. From this equation also we have written the value in terms of angle B, and we have substituted these values in the equation that the sum of the angles of a triangle is 180 degree. Now similarly in the next question it is given that angle A minus angle B is 33 and angle B minus angle C is 118. So the equation we will get from this is, we will write angle A is equal to 33 degree plus angle B. From this equation we will get angle C is equal to 18 degree plus angle B. Again what we have done, we have written angle A in terms of angle B, we have written angle C in terms of angle B. The equation from the triangle we have, that is angle A plus angle B plus angle C is 180 degree. We will substitute the value of angle A and angle C over here. So we have substituted the value of angle A and angle C over here. So the final value we will get it is angle B is equal to 55 degrees. And when you will substitute the value of angle B in these two equations, you will get the value of angle A as 88 degree and angle C as 37 degrees. So you can try to solve this question at your own, that how we are getting the values of the angles. Now in the next question, it is given that we are given a triangle ABC. It is shown in this figure, and we have the bisectors of angle B and C. Bisector of angle means we are saying this angle is equal to this angle is equal to this. So this, the value of this smaller angle, this is basically angle B by 2. The value of this smaller angle, it is angle C by 2. And what we have to calculate is, we have to calculate the value at angle O. So now we are having angle A plus angle B plus angle C, that is equal to 180 degree. Now in the smaller triangle we are talking about, in the triangle OCB, we will have angle O plus, now this angle we are saying it is angle B by 2 basically, and next angle we are saying it is angle C by 2. We have to calculate the value of this term. We know the value of this term, it is 180 degree. And what we have to calculate? We have to calculate the value of angle O. So angle O will be equal to 180 degree minus angle B by 2 minus angle C by 2. So that is equal to 180 degree. You take minus 1 by 2 common. So we are left with angle B plus angle C. And what is the value of angle B plus angle C? From this equation we are saying the value of angle B plus angle C, that is equal to 180 minus angle A. We put this value over here. So you will get it is 180 minus 1 by 2 into 80 minus angle A. 180 minus, now this is 180 by 2, so it is 90, then it is plus 1 by 2 angle A. So we are left with this 90 plus 1 by 2 angle A. So this is the value of angle O. The value at angle O, it is 90 plus 1 by 2 times angle A. Now in this next question, we are given a triangle ABC. So this is the side AB, this is side AC, and say this is the side BC. We have extended these sides and we are saying this is the point D and this is the point E. The given triangle is ABC. Now we have drawn the angle bisectors over here. These are the angle bisectors. Suppose this angle is X, then this angle is also X. Similarly, if this angle is Y, then the value of this angle is also Y, because these are BO and OC, these are the angle bisectors. Suppose we are saying this angle is W and this angle is, say, Z. So from these three angles I am talking about, we are having the equation 2x plus W is equal to 180. So from this we will get x is equal to 180 minus W by 2, that is equal to 90 minus W by 2. Similarly, from these three angles we have the value 2y plus z is equal to 180. So we will get the value of y is 180 minus z over 2, that is 90 minus z by 2. So these are the values of x and y we have. Now if I want to find this angle, then the value of this angle is 180 minus x minus y. Why? Because the sum of these three angles, this angle x, y and this angle, the sum of these three angles will be 180 degree, and this is what we have to calculate. So if we substitute this value over here, so we will get it is 180. I am talking about this angle BOC, that is equal to 180 minus value of x I have, it is 90 minus W by 2. In the value of z I have, value of y I have, it is 90 minus z by 2. So it is minus 90 minus z by 2. So the final answer I will get it is 180 minus 90 plus W by 2 plus minus 90 plus z by 2. So this 90 and 180 gets cancelled, and what we are left with is W plus z by 2. Now if I look at this triangle, say I am talking about the triangle ABC, the value of angle A is the sum of these three angles, angle W, Z and A, it is 180. The sum of these three angles, it is 180 degrees. So the value of angle A is, this angle A, the value is W plus Z, 180 minus W plus Z. So what we are talking about is that angle A is equal to 180 minus W plus Z. So it means value of W plus Z, that is equal to 180 minus angle A. So what, on dividing both sides with 2, I will get W plus Z by 2, that is equal to 90 minus angle A by 2. Now what we have is, we want the value of W by Z over here, and we have the value of W by Z over here. So if I substitute, I equate these two terms. If I equate these two terms, I will get that angle BOC, I am talking about this value, angle BOC, that is equal to 90 minus A by angle A by 2. Now in this next question, it is given that BE is perpendicular to AC. The value of these two angles is given, and we have to find the value of x and y. From this figure, you have to find the value of x and y. So we consider this triangle first. I'm talking about this triangle BEC. So in this triangle, what we have is, this angle is 40 degree. This angle is given to be 90 degree because it is given BE is perpendicular to AC. So in this triangle, we have to calculate the value of x. So we are saying 40 plus 90 plus x is equal to 180. So you will get the value of x is 50 degree. Now if we look at the triangle over here, this is ADC. I am talking about this triangle ADC. What we have is, we are talking about, this is the angle Y, this is 30 degrees, and this angle we have calculated, it is 50 degree. This is the exterior angle, and these two are the interior opposite angles, and we know that the value of exterior angle is equal to sum of the interior opposite angles. So its value is 80. So this is one of the procedure to solve. Second thing what you can do is, you can find the value of this angle. The value of this angle will be 180 minus 50 minus 30. Then the sum of these two angles is 180 is equal to y plus 180 minus 50 minus 30. So you can calculate the value of y, it will be again 80. So you can use any one of these two methods. Now next we are given a triangle ABC. Triangle ABC we are talking about. It is this triangle. This is AB, AC. This is our triangle ABC, and the side BC is produced to E. This is the side BC is produced to the point D. Now we are saying, we are given two angle bisectors over here. One is the angle bisector of this angle, this is BE, and second is the angle bisector over here. So angle bisector means, we are saying these two angles, these are equal, and over here we are saying these two angles, these are equal. We have to prove that the value of angle BEC, this angle we are talking about, this is angle BEC, this is half of the angle BAC. Now consider that the values of these angles over here, if this value is x, this is x, if this value is y, this value is y, and the value of this angle will be 180 minus 2y, because this angle, these two angles, these are y over here. So we will get the value of these angles is 2y, 180 minus 2y. Similarly, if we are talking about this angle is, this angle over here, this is 180 minus 2y. Now we write the values of these two angles. So angle A we are talking about, and angle E we are talking about. If we calculate the value of angle A, that will be 180 minus the angle at B, it is 2x, this whole angle it is 2x, and the angle over here it is plus 180 minus 2y. This angle is 180 minus 2y. So why? It is sum of the triangle is 180. So the value of angle A is the 180 minus sum of these two angles. Now if I am talking about the angle E over here, so the value of angle E will be 180 minus, now that one angle it is x, this is angle x for this triangle. Next we have plus y, and the next angle we have it is plus 180 minus 2 times y. These are the values of these two angles. So if we will solve these two equations, what we will get is, On solving the first one, we will get it is 180 minus 2x minus 180 plus 2y. So the value you will get it is 2y minus 2x. And on solving these equations, you will get it is 180 minus x minus y plus 180 minus 180, and last time you will get it is plus 2y. So 180 gets cancelled, and what you are left with is y minus x. So what we have now is that angle BAC, that is equal to 2 times y minus x, and angle we are calculating over here, it is BEC, that is equal to y minus x. So it means angle BAC is equal to 2 times angle BEC, and this is what we have to. You can write these equations in form of angles, or you can write them as x and y. It is up to you that how you want to solve these questions. Now in the next question, we are given a triangle ABC, and it is given that angle B is greater than angle, this angle B, this is greater than angle C. AD is the perpendicular, this is the perpendicular, and A is the angle bisector. So if A is the angle bisector, suppose we are saying this angle is x, then this angle is also x. These angles are given to be 90 degree. Then we have to prove that angle DAE we are saying it is this angle. Suppose the value of this angle we are saying it is T, is equal to 1 by 2 angle B minus angle C. Now if we write this angle over here, suppose we are saying it is y, and the value of this angle over here, this is angle Z. So in the triangle A B D A I am talking about, this is a right angle triangle. I have this angle is y, this angle over here it is 90 degree. So the value of this angle B, we have it is 90 minus y degrees. Similarly, if I am considering the triangle DCA, this triangle I am talking about, then what we have is this angle is Z. So the value of this angle over here, it is 90 minus Z degrees. Now what I have to calculate is, I have to calculate the value of angle B minus angle C. So if I calculate the value of angle B minus angle C, I will get this is equal to angle B, we are saying it is 90 minus y degree, and angle C is minus of 90 minus Z degree. So the answer we are getting it is 90 minus y minus 90 plus Z is equal to Z minus y. So one equation we are getting from this is that angle B minus angle C, that is equal to Z minus y. This is one equation we are getting from this discussion. Now second we are talking about is, if we look at the angle X, we are looking at the angle A over here. Now what we have is, I can write angle Y plus angle T, that is equal to X, or I am writing Y plus T is equal to X. So I will get Y is equal to X minus T. Similarly, in over here I will have Z is equal to X plus T. So now I am having two more values. One is Z is equal to X plus T, and second I am having Y is equal to X minus T. If I substitute both these values in the equation, so I will get angle B minus angle C, that is equal to Z minus Y, that we are getting from here. Then I put value of Z is X plus T, and value of Y is X minus T. So if I will solve these equations, I will get x plus t minus x plus t, that is equal to 2 times t. And what is this angle t? It is basically 2 times angle DAE. So what we get from this is that angle DAE, that is equal to 1 by 2 times angle B minus angle C, and this is what we have to prove. Now in the next question, we are given two parallel lines AB and CD, and T is the transversal. We are saying these are the two parallel lines AB and CD. T is the transversal. Now at the point E and F, we have drawn the angle bisector. These two lines over here, these are the angle bisectors. This EF and this EG and FG, these are the angle bisector, and they meet at G. So angle bisector means if this angle is equal to 2, then the value of this angle is also, measure is 2. Similarly, if this angle is 1, then the measure of this angle is also 1. Now, if I am talking about the two parallel lines are there, then the sum of these two angles, we know it is 180 degree because they are co-interior angles. These two angles, these are co-interior angle, and their sum is 180 degree. So what we get from this is that 2 times angle 2 plus 2 times angle 1, that is equal to 180 degree. So we get angle 2 plus angle 1 is equal to 180 degree, is equal to 180 degree by 2, that is equal to 90 degree. Now if we look at the triangle, this triangle I am talking about, it is a triangle EGF. We have angle 1 plus angle 2 plus angle G, that is equal to 180 degree. The value of angle 1 plus angle 2 I have, it is 90 degrees. So I put 90 plus angle G is equal to 180. So I will get the value of angle G is 90 degrees. And this is what we have to prove, that value of angle G, it is 90 degrees. Now in the next question, a triangle ABC is given and it is right angled at A. This is right angled at this A. This is our vertex A and the triangle is right angled at A, and L is a point on BC such that AL is perpendicular. Again we are saying this is perpendicular over here. AL is perpendicular on BC. We have to prove that angle BAL and angle ACL, they are equal. So how we are going to prove this is, we will consider that in the first right angle triangle we are talking about, it is ALB. The sum of the angles will be 180 degree. It means the sum of these two angles is 90 degree. The sum is 90 degree because the third angle is already given to be 90 degrees. I am talking about this triangle over here. In this triangle we are saying, now in the second case we are talking about that the angle at A is 90 degree. So what we get is that the sum of these two angles, the sum is 90 degrees. So if we write, suppose this angle we are saying it is X and the value of this angle we are writing it is Y. So what we get is, from this we are getting X plus angle B, that is equal to 90 degree. From this we are getting it is Y plus angle B, that is equal to 90 degree. You subtract these two equations, you will get X minus Y is equal to 0. So you will get X is equal to Y, and this is what we have to prove is that this X and Y, they are equal. Now next we have to prove is that the bisector of the base of angles of a triangle can never enclose a right angle. Can never enclose a right angle means it cannot be greater than equal to 90 degree. So we are saying, suppose a triangle ABC is given to us and we have drawn the bisector of the base angles. Bisector of the base angle means that this angle, if this value is x, then this value is x. Similarly, we are saying if this value is y, then this value is y. And what we have to prove is that the value of this angle at O, this is always less than 90 degree. Now, if from the triangle OBC we are talking about, from the triangle OBC we are saying the value of the angle O will be, the value of this angle will be 90 minus x minus y. Now we are saying it is 90 minus x plus y. If suppose the value of this angle O, we are saying it is equal to 90 degree. If this value is equal to 90 degree, then what will happen is that the value of x plus y you will get, it is 90 minus 90 is equal to x plus y. So the value of x plus y is equal to, you will get it is 0 degrees. And this is not possible. Now suppose we are saying if value of x plus y is greater than 90 degree, it will become 90 minus x minus y is greater than 90. Suppose I am supposing the value is say 91. It may be any value over here. Then what will happen is 90 minus 91. Suppose I am saying it is equal to 91. I will get it is equal to x minus y. So the value of x minus y, value of x plus y, I will get it is equal to minus 1 degree, and again this is not possible. So same thing is explained over here. We are saying that if possible, then angle BOC, that is equal to 90 degree, then angle CBO plus angle BCO, that will be 180, and what we will get is that angle A is 0 degree. In this triangle, the angle A will become, it is 0 degree, and it cannot be true because ABC, if angle A is 0 degree, then ABC will not form the triangle. So our assumption that angle BOC is equal to 90 degree is wrong. Similarly, if the value is greater than 90 degree, the value of the angle A you will get it is negative, which is again not possible. So we are saying that the bisector of the base of the angles of a triangle can never enclose a right angle. Can never enclose means they cannot be greater than or equal to 90 degree. Cannot be greater than equal to 90 degree. Now in this next question, this figure is given to us and we have to prove that this angle x, that is equal to the sum of the angle alpha plus beta plus gamma. So what we are going to do is we have constructed a line over here. This line BDE we have constructed. So what we get from this is, and we have marked some other angle, that is S, T, P, Q, all these angles we have marked. Now basically what we have done is we have divided the whole figure in two triangles. One is this upper part and second is this lower part. So if I look at the upper part over here, this is the line given over here and we are talking about the triangle on the upper part. So what we have is this angle S over here, this is the exterior angle and this is sum of the interior opposite angles. So we will get the value of S will be equal to P plus alpha. Similarly, when we are looking at this angle T, this is the exterior angle and these two angles Q and gamma, these are the interior opposite angles. So what we get is the value of T is Q plus gamma. Now the value of X we have, it is S plus T. Now substitute the value of S, substitute the value of T, you will get it is alpha plus P plus Q plus gamma. Now what is the value of P plus Q? If I'm talking about P plus Q, this P plus Q is over here, and the value of P plus Q is equal to beta. So the final answer I will get it is alpha plus beta plus gamma, and this is what we have to prove, that x is equal to alpha plus beta plus gamma. Now next is the sides BC of the triangle ABC is produced to D. So a triangle ABC is given to us and the side BC is produced to D. The bisector of angle A meets, bisector of angle A means if this value is x, then this value is also x, the value of the angles we are talking over here. Both the angles, these are x, and they meet at E. We have to prove that angle ABC, we have to prove that the angle ABC, this angle, plus angle ACD, we are talking about the angle ACD, this is this angle, that is equal to 2 times angle AEC. We have to prove that the sum of these two angles is equal to 2 times angle AEC. So I also mark these as, suppose I am writing this is Y, this is Z, and this is W. So what we get is Z is the exterior angle, X and Y are the interior opposite angle for Z. So the equation we get is Z is equal to X plus Y. Similarly, W is the exterior angle, so we will get it is equal to X plus Z. This is X and this is Z. So we get two equations over here. First equation is Z is equal to X plus Y, and second is W is equal to X plus Z. Now we find the value of X from both these equations. From this you will get it is X is equal to W minus Z. From this equation you will get X is equal to Z minus Y. We equate these two equations and we will get W minus Z is equal to Z minus Y. So it is W plus Y is equal to 2 times Z. Now what is W we have? It is angle ACD, plus what is Y we have? It is angle ABD, or you can write it as ABC. And what is the value of 2Z we have? It is 2 times the value of Z is angle AEC, and this is what we have to prove. Now in the next question we are given a triangle ABC, and it is given that it is an isosceles triangle with AB is equal to AC. It is given that AB, that is equal to AC, and AE is the bisector of angle CAD. So we are saying this is the bisector of angle. If this angle is X, then this angle is also X. Now we have to prove that AE is parallel to BC. We have to prove that AE is parallel to BC. Now if the sides AB and AC, they are equal, it means that the angles over here, these two angles, these are also equal. So we are saying if this angle is Y, then this angle is also Y. Now what we have is, if we calculate the value of the angle CAD, that will be equal to angle B plus angle C. What we are talking about, this angle over here, this is the exterior opposite angle, and these two are the these are exterior angles and these are the interior opposite angle. So from this what we get is that 2x is equal to 2y. The sum of these two angles it is this, and sum of these two angles it is 2y. So we get x is equal to y. Now look at these two lines over here. This is the line AE, and second I am talking about, this is the point C over here, and this is B over here. What we are saying, we are considering the line AE and we are considering the line BC. This is AE and BC. Now this AC will be the transversal. This AC will be the transversal. And what we have from here is, if this angle is X and this angle is Y, we have seen that X is equal to Y. So if these two angles, these are equal, these are basically the alternate interior angles. We are saying these are the alternate interior angles. So when the alternate interior angle, they are equal, so the result we have is that the lines, they are parallel. So we get AE is parallel to BC. Now in this next question, we have to prove two things. One is that angle ACD, this angle ACD, this is equal to A plus B. So basically we are talking about that the exterior angle is equal to sum of interior opposite angles. And second thing we have to deduce from this is that the sum of angles of the triangle is 180 degree. So what is given to us over here is that ABC is the triangle and CD is produced over here. So if I look at these two lines over here, you can try to give a reading to this question. It is not that difficult. So I am just explaining what is given over here. This is AB is a line and this is EC is the line over here. So we have two transversal over here. One is the transversal like this, AC we have drawn, and second transversal we have it is BC over here. So what we get from this is, when we are considering this AC as the transversal, what we have is that this angle A over here, this is angle A, that is equal to the angle ACE. This is the transversal. We are saying these are the two parallel lines. This is one line, this is second line, this is the transversal. So both these angles, these are equal. This is also equal to angle A. Second thing we are talking about is, if we are considering again, these are the two parallel lines, and if we consider the transversal this BC, then what we have is, this is angle B, and for this transversal we are saying, we are having this is equal to angle B. So what we get from this figure is that this whole angle I am talking about over here, this whole angle I am saying, the value of this angle is angle A plus angle B, and this is equal to angle ACD. And this is the first part that we have to prove, that angle ACD, that is equal to angle A plus angle B. Now I am talking about this third angle. This is angle C. Now all these three angles A, B and C, they lie on a line. So we are saying that their sum will be, sum is equal to 180 degree, and this is what we have to prove in the second part. So you can just read this, that how we are proving these two things. Now in the next question, it is given that ABC is a triangle. The value of angle A is given to be 70. Value of angle B is given to be 52. We have to calculate the value of these two angles. This is O and this angle over here. Further, it is given that BO and this BO we are saying, and this OCO we are saying, these are the angle bisectors of B and C. So if we are talking about the triangle ABC, the sum of the angles is 180 degree. So we get it is 70 degree plus 52 degree plus C, that is equal to 180. So value of angle C you will get it is 180 minus 122, that is equal to 58 degree. So this whole angle is 58 degree. Now half of these angles, half of 52 degree is 26 degree, and half of this angle is 29 degrees. Now in triangle BOC, in this smaller triangle we are talking about, in this triangle, again the sum of the three angles is 180. So we get it is 26 plus 29 plus angle O, that is equal to 180 degree. So the value of angle O you will get is equal to 180 minus 55, that is equal to 125 degrees. And this is what we have to calculate. We have to calculate the value of this half of angle C, and we have to calculate the value of angle at. Now in the next question, we are given that PQ is perpendicular to PS. These are perpendicular. Second thing that is given to us is that PQ is parallel to SR. We are saying this PQ and SR, these are parallel to each other. Then the value of angle SQR is 28, QRT is 70, and we have to find the value of X and Y. So this is 70 degree over here, this angle and this angle, these are the interior opposite angles to this exterior angle. So what we get is, suppose this value we are saying it is Z, so we get Z plus 28, that is equal to 70. So the value of Z you will get, it is equal to 42 degrees. Now look at the line PQ and SR. There is a transversal over here. We are talking about, this is the line PQ and this is the line SR. This is the transversal line T. We are saying this line is the transversal over here. This is the line PQ, this is the line SR, and transversal we have. So what we have is that the value of this angle over here and this angle over here, these are equal because these are alternate interior angle. So this angle 42 will be equal to the value of X. So the value of X you will get, it is 42 degrees. Now if we look at the triangle, we are saying, we look at the triangle over here, it is P, Q and S. We are saying P, Q and S. This angle is 90 degree. This angle obtained we have, it is 42 degree. So the value of this angle will be 90 minus 42 because this angle is 90 degree. So the answer you will get, it is equal to 48 degrees. So the value of Y we will get, it is 48 degree. So these are the answer. Y is 48 degree and the value of X is 42 degrees. Now in the next question, it is given that line AB and line CD, they intersect at P. Then the three angles are given to us and we have to find the value of rest of the three angles. We have to find the value of this and this angle. So what is the value of this angle? If we look at the triangle APC, then this angle will be equal to 180 minus 100 plus 45. It is a triangle. Sum of the angle should be 180. So we will get, it is, suppose it is X. So we will get X plus 100 plus 45 is 180. So the value of X you will get, it is 100 minus 180 minus 100 plus 45. So the answer you will get, it is 35 degree. This angle is also X because these two angles, these are vertically opposite angle. Vertically opposite angle means we are saying two lines, they are intersecting, then these two angles, these are vertically opposite angles, and these two angles, these are vertically opposite angles, and we know that vertically opposite angle, they are equal. So the value of this angle is, again, this is 35 degrees. Now we consider the triangle over here. It is P, B, D. This is P, this is B, this is D. The value of angle at P we have 35. Value of B, it is given to be 65 degree, and the value of D you will get, it is 180 minus 35 plus 65. So you will get, it is 180 minus 100, that is equal to 80 degrees. So the final answer you will get, it is these three angles are 35 degree, 35 degree and 80 degrees.